This is 8.3, the beta lesson, and then the 4-step process we told you. I'm not really concerned about that. You're just going to follow the template. The alpha version of the template is in Canvas Chapter 8 folder. The beta version, which the template's filled out for you, is in the Chapter 9 Canvas folder. So here's an example. Ready? This problem we did in 8.2 about the proportion of Americans that read a book. So now they're looking at the same data set. Instead of the proportion of Americans who read at least one book in the last 12 months, they said, how many books? Okay? And the mean was 12 books, except the step was 18. So you want a 95% confidence interval for the mean number of books read by all Americans in the previous 12 months. And then 5 years before that, Pew reported that American adults are on average of 14 books in the previous 12 months. So we go here. You can't just build the confidence interval. You have to identify what you're doing. You have to come up with the conditions. The math part of it is just one step. So what am I trying to find? A 95% confidence interval from you. The Greek letter is telling you that's the parameter. So we're doing a one sample T interval. How about the conditions? SRS. Ready? This condition right here where it says random. You don't have to write this. You can just write SRS. It's understood. College Board accepts SRS as an abbreviation. Now what? 1,520 is your sample size. That's less than 10% of American adults. Okay? And then the sample size is greater than 30. So we're good with the conditions. So what's happening? We would have 12. 12, which was the mean, add or subtract the critical value. And where are you getting the critical value? You want a 95% confidence interval, but in effect, what are we doing? The sample size is so large, we're really using a normal distribution. Because the t distribution, we push down on it for the scale change to compensate for a smaller sample size. You could just use 1.96. You don't even need this 2. You're using the z value because the sample size is so high. Step divided by the sample size, and you get, in effect, basically between 11 and 13 books. You're 95% confident that the parameter is between 11 and 13 books for all American adults. Now, what about this? How about from 2011? 14 is outside the confidence interval. It provides convincing evidence that in 5 years, the mean has changed. Now, maybe the 2011 data was incorrect, but 14 is not in the confidence interval. That gives you evidence that the mean has changed. Next thing, you have these excuse me, video terminals. You want the mean, right? And the random sample size 20. You want a 90% confidence interval. You good? And you have these 20 data points. You're going to put these 20 data points into your calculator. What does that look for, Andrew? It seems like busy work. We're not doing that. I did it for you. You just have to follow this. Okay? But you have to understand what's being done. You want a 90% confidence interval. We wanted one sample T interval. SRS, yes. 20 is less than 10% of all video terminals, yes. Except what? Our sample size is not large enough. It's not 30. You good? That doesn't mean we stop. Now, in the book, they drew this dot plot. That's not what's going to happen. If you got this question in May, you have to do this. You have to build a box plot and literally draw the box plot on your solution, freehand. So, don't spend time putting this in your calculator. I did it. You're welcome. There's somebody who's great. So I put all those values in a list. Whoa, sorry. And there's the box plot. So what do you notice with the box plot? It's symmetrical. So if the graph looks like, there's the distribution, and that is actually what you would do in May. You would draw this thing and show, well, look at this thing. It's, and you can trace it. You don't really need to. There's the median, okay? You could go for the min and 5-number summary. But the point is the shape of that. The shape is symmetric. So I can move forward. I don't need the sample size to be 30 because I'm confident that distribution is symmetric. Okay, so don't, ready, ignore the dot plot. It's on the PowerPoint. You're going to use a box plot if, ready, if the sample size is large enough. If it's greater or equal to 30, you don't need the box plot. But if the sample size is less than 30, yes, draw the box plot and be sure that the graph is symmetric. But what if it's less than 30 and the graph's not symmetric? Correct. That could happen. You still move forward, but you say the condition wasn't met. So here's the interval. Are they getting this? Here is the mean value. Here's the critical value. So let's make sure we can find this critical value. On your calculator, ready? It's a 90% confidence interval, and the sample size is 20. So you'd have 19 degrees of freedom. So you're going to inverse T, second distribution for, it's a 90% confidence interval. So you would type 0.05. Because it would be 5% of the left tail and 5% of the right tail. 0.05, comma, 19, because there's 19 degrees of freedom. And you would get negative 1.729. Well, if you type 95%, you get positive 1.729. The graph's symmetric. So this is your critical value times what? The standard deviation over the square root of the sample size. You would get 292 1/3, 320 1/3. You are 90% confident that mu is in that interval. Now, this is what I just told you. If you're assessing the normality of the distribution, you must sketch the graph on your paper to receive credit. And then we say, don't multiple graphs. Yeah, correct. You don't need a dot plot and a box plot. Box plots are what we're using in here. You draw the box plot, make sure you can do the stat plot on your calculator, and you just draw it freehand on your solution. Now, same thing we did with proportions. How do we identify the minimum sample size? Here's our margin of error. The margin of error is just half the width of the confidence interval. Where are we getting it? The critical value, which is a t when we use the statistic for the spread. So this algorithm would change. It would be z asterisk times sigma over root n. But most of the time, we don't know sigma. And that's why we're using the t distribution. So what do you want to do? Well, we've got 1, 2, 3, 4 unknowns. If we identify 3 of them, we can solve for n. Same thing as we did for proportions. If you were in the room last year, and you have AP cast in your groups, then you have sample. The sample program does this for you. We will get this done for you in the new building. Everybody will have it. Yes, by Eric, who is sampled by Eric, who is Eric Ulmer. You recognize that name? Is his name on Canvas on the front page? Yes. Because Eric Ulmer got a 5 in BC and in statistics. He's smart. Yeah, that's why you should pay attention to the program. So, you got a problem here, right? The critical value depends upon the sample size. So how are we going to do this? We're going to go back and say to the z distribution, because if we did what they just asked us to do, work backwards, we don't know what t is without knowing what n is. That's what we're trying to find. So we're going to go back to as if we knew the step, the parameter, this the Greek sigma. So here's the example. You know what your estimate is going to be. 1. And you want a 95% confidence level. And a previous study suggested the standard deviation is about 5. What's the minimum number of monkeys you would need for your study? You go here. I want a 95% confidence level, so I'm using the z-score, 1.96 of 5 we got from previous data. And we want the margin of error to be less than or equal to 1. So the root n is the only thing we're missing. And that's telling us we would need a sample size of 97. Okay, you have to round up. All right, and there's the bullet points. So we tried to put this in here on the PDF so you can compare and contrast the two sections. All right, and we're looking at this. confidence interval from mu. X bar is the statistic. Add or subtract T times the standard error of X, the margin of error, the whole thing. What is the standard error of X? The statistic divided by root n. So this, ready, is what we have for proportions. And for means, you see what happens. This T, the T corresponds to using the statistic. The Z corresponds to using the parameter. Well, we can't work backwards to get this A, because we don't know N, we don't know what the T, what the degrees of freedom would be to find T. So we use this algorithm. We assume that, use the parameter values in order to work backwards to get it, okay? So we're going to pause this and ask you to go to two questions, 73 and 75. Okay, so for 73, the right side of the screen is using the T interval from stat test. The left side is doing the work. Ready? Here's the critical value. 2.5% in the tail, 9 degrees of freedom. The sample size is 10. You get 2.262. So what are you doing with that critical value? You're multiplying it by what? The step divided by root 10. So that's your standard error. And you get an interval from 32 to 43. Essentially, slices of pizza. You're 95% confident that the parameter is between 32 and 43. Here's the box plot. Okay, your sample size is not large enough to assume normality, but the box plot is essentially symmetric. That would go with your conditions. The restaurant is claiming 40 slices or 40 slices of pepperoni. Yeah, that's in the interval. There's a lack of evidence to reject the manager's claim that they're putting 40 slices on each pizza. Okay? So that's that for beta.